Hi, some of you may remember I recently coded this thing. By the way, it's going to be linked in the description. Today I'll be doing another take on the cube of bubbles concept. This is going to be inspired by the animation you see right here, which I'll be combining with the current CodePen challenge, which is light to dark, except I'll be doing more out of the dark into the light. Had to sneak in a creator reference there. Anyway, let's get started. And we will begin by setting the number of bubbles per cube edge. This is going to be 5 initially because we don't want to have too many elements. We don't want to risk performance issues early on. Next, we're going to compute the total number of bubbles per cube face. This is going to be p, and it's going to be n squared. Okay? Finally, we compute the total number of bubbles per cube. This is called q and is computed as n cubed. Then we put all of our bubbles within this 3D assembly. And in case you're wondering why aren't we just dumping them straight into the body, that's because they all need to be within the same 3D rendering context. And what that is and what issues can appear, that's all detailed in this article that's going to be linked in the description. Now let's go back here and we're going to have a loop. So while q gets decremented and is still positive, we have our ball elements. And before we move on to putting something on the screen, we are going to pass that n value to the CSS in a style attribute as a custom property. Okay, now having done this, we are going to set on the body and on all div elements display grid. Next, on our 3D assembly, we are going to set a grid template. Now we're going to have the same template for both the rows and the columns, so we'll be setting it as a custom property. It's going to be a repeat n rows and columns, and we're going to have the same horizontal and vertical dimension, which we'll be setting to, let's say, I don't know, 1.5 ems, let's say. And we're going to need to interpolate that because it's the value of a custom property. Okay, so we have grid template, that same custom property for both the rows and the columns. Now the next step is going to be to make those ball elements show. So we're going to set box shadow, 0 offsets, 0 blur, 2 pixel spread, and black. Black is also the default, but yeah, I'm just setting it there. Anyway, notice one thing, how that line at the bottom is thicker than the lateral ones and the top one. And that's because we have the first P of those Q elements. The first P elements are on that n by n grid, and the following ones, our template doesn't reach further. The following ones just get high to 0 and they're all collapsed there at the bottom. That's not what we want. We want n grids of p elements. P elements meaning n by n grids. And these grids are stacked along the axis that points out of the screen towards us, okay? So they're stacked along that axis, and that axis isn't going to point right out of the screen towards us once we rotate the assembly, because that also rotates the elements coordinate system. But yeah, more on that a bit later. For now, we want to have n grids, okay? So we are going to need an index for the columns. This is going to be an index along the x-axis, and it's going to be I. We're going to need an index for the rows. This is going to be an index along the y-axis, and it's going to be j. And then we're going to need an index for the grid. This is going to be along the z-axis, pointing towards us at this point, right? And it's going to be k. Okay, so the grid index is going to be k, the column index is going to be I, row index is going to be j. So let's set those indices in this style element. We're going to start with a loop, so for let I starting from 0 going all the way up to n, increment this I, and first up we are going to set that I, so ball nth child. So every yeah, that's not CSS, every n elements, and here we're going to have I plus 1, and it's plus 1 because the nth child index is 1 based, as opposed to loop index, which is 0 based. Also, the grid row and grid column indices in the CSS are going to be 1 based, so we are going to need to add 1 to these values that we set here as custom properties. So we have our I, the index, the column index. Now, as I mentioned, these are every n elements because we have n elements on a row, and after we've passed the first n elements, then everything repeats. So, okay, these are all going to have the same index, these are all going to have the same I index, these again are going to have the same I index. So 0, 1, 2, 3, 4, okay? Every n elements, because we go like this, then like this, and then like this, and then we move on. Once we're done with this grid, we move on to the next grid, and so on. So next, we are going to set that k because it's easier than the j. So let's get rid of that part right there. So after all the items on the previous grid, so for the first grid, we don't have any previous grids. So this is going to be I 0 times p is going to give us 0. So starting from the first one, right, we are going to have k set to 0. Now, after we're done with the first grid, the grid of index 0, we move on to the second grid, the grid of index 1, and we are going to have after 1 times p, okay, so after all the elements on the first grid, and then when we move on to the third grid, we are going to have after 2 times p. So after 1p is going to be the first grid, the second p is going to be the second grid, okay? So p elements on the first grid, p elements on the second grid, and on the third grid we are going to set after all the elements on the first and second grid, p plus p, or like this. Okay, now let's move on to the j, which is a bit more interesting because we can't say after all the elements on the first row just like that, because then we move on to the next grid and that doesn't work anymore. So with the row index, it's a bit more complicated. We are going to have a list of limits. So basically we are going to have after all the rows on this grid before the current row, but before all the rows on this grid after the current row. And we're going to do this for all the grids. Basically, we are going to have a list of interval selectors. So one is going to determine the lower limit, the other one is going to determine the upper limit. Okay, we are going to have a list of n such selectors for each of our n grids. So we are going to start with an array. So this array is initially going to be empty. And we're going to have a second loop that is going to give us how many elements do we have before the current grid. So that's what we add to the array. But of course, first we need to change the loop index right here. Change it to j. So we push into this array j times p. So this is the number of items before the current grid. Now here our selector is basically going to be a list. So here we can just interpolate an array, and the commas in between the items in the array just get added automatically. But it's not going to be just those numbers. That's not the array. We're going to map this array to an array of selectors. So the current item is going to map to ball, and we're going to have first the lower limit, nth child, n plus, and here we interpolate the current value, which is the number of items on all the previous grids, plus here we're going to have I times n, which is the number of items on all the previous rows on this grid, plus 1, because as I said, nth child index is 1 based. And after we're done with this part, we're going to have the upper limit, which is nth child n plus, and again we interpolate, k, which is all the items on the previous grid. And then we are also going to include the items on this current row to get the upper limit, so I plus 1 to get the upper limit of the items on the current row, times n. Okay, and now that we're done with the selector, we are going to set j to the loop index. And soon you're going to see this working. Before I forget, let's set transform style preserve 3D. This allows us to have 3D transformed elements, these balls, within another 3D transformed element, and not have them flattened in the plane of their parent, which is this 3D assembly. Okay, now this again, it's something that's explained in this article, which is going to be linked in the description, blah blah blah. Okay, now let's put this in the middle because it bothers me to see that. Place self center, and this only looks like it worked horizontally, and that's because at this point the body still has the height of its content, which is this 3D assembly. So let's fix that part on the body, set height to full viewport height. Okay, this puts the thing correctly in the middle, but we now have that ugly scroll bar, which is caused by a margin on the body. So if we zero that, then we get rid of the scroll bar, as you can see. But of course we can also go full nuclear and just set overflow hidden. And just to be done with the body part, let's also set a background. This is going to be linear gradient, and it's going to go from white to black, light to dark. Now let's just collapse that element, and actually we're going to maximize the CSS. Okay, now the next step is going to be setting a transform here. So we're going to set a transform, and we're going to have translate along the z-axis, and here we're going to have calc, and at first we're going to use k times that edge length, and this doesn't look like anything, so let's add a transform here. Now we're going to want to rotate this cube such that, as you can see, it looks like we have one corner there, and that corner is supposed to coincide with the corner in the back. It's probably going to be a bit more obvious here. So this corner right here, we want it to coincide with that corner in the back. Now if we were to look at everything right from the front and not a bit from the side of this edge right here, right, we'd only see this face, right? So bringing these such that they are on the same line that's perpendicular onto the screen, this means rotating the diagonal, right? Rotating the cube diagonal such that the cube diagonal between these 2 points, not the other one that I'm pointing there, though they kind of seem to coincide due to the angle we're seeing this from. But anyway, the diagonal between this point right here and this point right here, bringing this diagonal perpendicular onto the screen. So this means that we need to rotate horizontally by this little angle right there. How can you get that angle? Well, its sine, it's x over d, which is the cube diagonal. So how do you get d? Well, it's all explained right here, and d is x times square root of 3. So the sine is x over x times square root of 3, or 1 over square root of 3. Now we also want these two edges, that edge in the back and this one edge in the front to look like they're the continuation of one another, like they're on the same support line, on the same vertical support line. Now we do that by bringing this diagonal into the plane of the screen and making this diagonal perpendicular onto the screen. So how do you bring this into the plane of the screen if this front edge is in the plane of the screen? Well, we rotate by this angle right here, and the tangent of this angle is x over x, or 1. So let's get back here and compute those angles. First, we are going to use this module, because otherwise we don't have trigonometric functions. So our rotation around the x-axis is going to be arc sine of 1 over square root of 3. And then we're going to have arc tangent of 1. So these are the angles. Let's set transform, rotate x, and this is going to be minus let's see it, rotate y, sorry. Okay, now this looks really weird because as you can see they're all just the lines there, and that's because they're not all the items after the first grid, they're not placed on grids themselves. Let's fix that part. So here we're going to set grid area, so the row index is going to be j plus 1, and the column index is going to be I plus 1. So I've been using indices from 0, starting from 0, but the problem is these indices are not how the indices for CSS grid work, and that's something seriously wrong there. And I mean it, seriously wrong there. Okay, let's see it. Oh, I got it now. This was minus n. So the end interval, that was, okay, that fixes it. Okay, that was a really silly mistake. Now, having figured that one out, let's also set border radius 50%. And as you can see, those don't quite look like bubbles, they just look flattened into the grid planes. So we are also going to add rotations to reverse these ones. So we reverse them in the reverse order that we've added them there. And finally we have the rotate x. Okay, so this is starting to look like something. And we can set the background, we can make them a plain color, or we can make things more rainbowy, more interesting. Let's set an HSL value that is going to depend on 2 of the 3 indices. So let's say that the hue is going to be I plus okay, this we are going to divide by n, and we're going to multiply not with a full rotation 360 but with 200. We're going to have something close to maxing out, something like that. Okay, this should do it. So this is starting to look pretty nice. Now the next step is going to be adding some animation. Now this is going to mean bringing those bubbles up, so they're going to be translated up a bit in the other directions, in the X and Z direction, not just along the Y axis up. Okay, and they are going to be translated with slightly different delays. So we're going to have a time factor, right, to control that slight delay, and then we're also going to get the translation values, the X and Y, and then we're going to have a factor for the Z axis. And why we can't have percentages along the Z-axis is something that's explained in this other article. So responsive 3D shapes using percentage values. The thing is, the transform value in percentages along an axis is, that percentage is relative to the size of the element along that axis. And along the Z-axis, all elements being flat, they have size 0. So whatever percent of 0 is always going to be still 0. Now let's say we are going to have an X value, and this is going to be 50% plus at most 100%, so a random value from 0 to 100. We are also going to want to have a random sign, and we get a random sign by raising -1 to the power of either 0 or 1. So -1 raised to either 0 or 1. So we're going to have round a random value. So a random gives us something between 0 and 1, and if we round something between 0 and 1, then this is going to be 0 if this value is smaller than 0.5 and 1 otherwise. Okay, now we are going to want to round this whole thing. For the Y, it's a bit easier. Let's say that we are going to have 100%, yeah, we don't write percentages there, plus n times 100, or we could make this bigger, 150 or something, times the random function. And of course we're going to want this percentage to be an integer. And finally, here we're not going to have a percentage, we're going to have a factor, and this factor is going to be very similar to what we have right here. So in a way it's going to be kind of like that, except here we're going to have 0.5, and here it's not going to be 100, it's going to be 1. Okay, and we're going to want to have at most 2 decimals. We can't round it because, yeah, it's going to be between 0.5 and 1.5, so yeah, rounding it isn't really going to help. We're going to want to have 2 decimals here, and as I said, we're also going to have a time factor, and this is going to help us with the delay. This time factor is going to be, so here we're not going to have any sign because this is not going to be negative. This is going to be at least 1, and we can add up to 3. Yeah, why did I didn't mean to round it there. Okay, so now here, oh yeah, I can't type. Okay, this is it. We just need to set them in a style attribute. So we're going to have X, and that's going to be percentage, right? Then we're going to have the same for Y, and then we're going to have the factor, and this is going to be just unitless, it's not going to be percentage or anything, and the next factor the exact same, so except this is going to be the time factor. Okay, now having done this, let's move on to the animation. Let's first set an animation duration here, so 4 seconds, let's say, and here we're going to have keyframes move, right? So we're going to have one state from 0% to 50%, and then after that, so up to 75%, we're going to have that go up and dissolve to nothing animation, and it's going to stay in that state, scaled down to nothing, so translated up and scaled down to nothing. It's going to stay in that state up until 100%. Now, first thing, set this as position custom property. Then we have transform, and now it's going to become 3D again. Yeah, we need to interpolate this because they're inside a value for custom property, right? Okay, now it's 3D again. We are going to take this, and this is going to be our 0 to 50% state, and in this other state we are going to start from this position, from those transforms that give us the position of the bubbles, and then we're going to have a translate 3D where we're going to have that X. And by the way, I just realized I haven't set the minus sign here, so these are all going to have the same sign, and it's going to be minus because they go up and the positive direction of the y-axis is down. So y, and for the third dimension we're going to have the factor times the edge length L. Let's see. Okay, now having done this, let's add our animation here. We are going to have that move animation T ease out, and let's see it infinite. Okay, and then we're also going to want to have a scale to 0, so they're also going to scale to nothing. Okay, it's starting to look like something, but we don't want them to animate at the same time. We're going to want to have that slight delay, and this delay is also going to depend on the index along the y-axis, so on that vertical index. So we're going to have calc that vertical index j, then we're also going to use that time factor, right, and this sum will be dividing by n and then by 6 and multiplying with this. Let's see it. Okay, you can kind of see. We don't want them to reappear in that ugly way. We are going to control the opacity, so they're basically going to fade in. Let's collapse this set of keyframes, and we're going to have a second one for the alpha. So here we're going to have from 0 to 25%, opacity 0, and then we are going to have from 50% to 100%, opacity 1. Now we're going to add that animation as well. Same animation duration. Ease in out, infinite, let's see it. Okay, so you can see how it shows up. And okay, the next thing is going to be making the whole thing slide up as it fades in. So we are also going to set this to a custom property, and just like before, we're going to need to interpolate these, because otherwise you can see how the thing looks broken. Of course, we're not even setting a transform. That's another cause. Okay, now everything looks fine again, and we are going to take this alpha set of keyframes, because this is actually what we want right here. This is going to be Y, and of course here we're going to have transform. So why the hell am I not just copying the whole thing? So like that, and in this case right here we are going to have another transform function. No, actually it's going to be the initial one, right? Because the final state is right. Sorry about that. So we don't want it to slide out at the end. So here we are going to add a translation, and this one, let's say that it's going to be n times, or maybe bigger, I don't even know, let's say 1.5, and let's add in that animation. So that's going to be Y, that same animation duration, ease out, infinite, let's see it. Okay, this looks pretty cool, and we can make it look even cooler if we change the number of bubbles per edge. Let's see that. Oh, this is getting things out of sync. So let's make sure this is safe, and let's move on to debug mode. Okay, this looks much better, so we don't get that out of sync effect. So I'll be leaving it at this. I'm not going to be tweaking it any further. I hope you've enjoyed this video, and if you have, if you like the work that I'm putting out since early 2012 and you want me to be able to do more in the future, please consider supporting it. You can do so by being a cool cat and becoming a patron on Patreon, or if monthly support is not your style, there's the option of a one-time donation, or you can make me happy with a gift off my wish list, or you could at least share this to show the role what can be done in CSS these days. In any event, thanks for watching. The links for everything, for the finished demo, for all the resources mentioned here, for my Patreon and everything else, they're all going to be in the description, and I'll see you next time. Bye!